Hi students, let us try to understand the Ohm's law from the NCERT book. What is the Ohm's law? If you see, is there a relationship between the potential difference? Potential difference means B across a conductor and the current through it. Current is I. Let us explore with an activity. Okay, they are saying that is try to understand with activity. Set up a circuit as shown in figure 12.2 consisting of the nichrome wire XY of length say 0.5 meter and a meter, a voltmeter and four cells 1.5 volt each. Nichrome is a alloy of nickel, chromium, manganese and iron metal. Okay, so what you are going to do, that is you placed each and everything here, right? Now what they are saying, first use only one cell as the source in circuit. Note that reading in the ammeter ammeter I for the current and reading of the voltmeter V for the potential difference across the nichrome wire XY in the circle. Tabulate them in the table given. Next, connect two cells in the circuit and note the respective reading of the ammeter and voltmeter for the value of current through the nichrome wire and potential difference across the nichrome wire. So what we are going to do, the connect two cell in the circle. Firstly, that is what is only one cell. Secondly, we are connecting two cell, okay, in the circuit, and then we are going to read out the everything. Repeat the above step using the three cell and then four cell of the circle retroactively. Calculate the ratio of the potential difference V to I for each pair of potential difference. So you will get some current through the nichrome wire you will get here, and the potential difference you will get, and that is B by I also volt, and this you will get. So let us try to understand. BI graph of the nichrome wire, a straight line plot so the as the current through a wire increases, the potential difference across the wire increases linearly. This is Ohm's law. Okay. In this activity, you will find that approximately the same value of V by I is obtained in each case. Thus, the VI graph is a straight line that passes through the origin of the graph as shown in figure 12.3. Thus, VI is the constant ratio. Okay, VI is the V by I is the constant ratio. What the point in this activity, you will find that approximately the same value for Vi is obtained in each case. Thus, V by I graph is a straight line that passes through the origin of the graph. In 1827, a German physicist, George Simon Ohm, 1787 and to 1854, found out the relationship between the current I and flowing in a metallic wire and the potential difference across its terminal. The potential difference V across end of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. This is Ohm's law, in other words, V proportional to I. V by I is constant is equal to R. V is equal to, you can put IR. In equation 12.4, this equation V proportional to I. R is constant for the given metallic wire at a given temperature is called resistance. It is property of conductor to resist the flow of charge through it. The SI unit of its SI unit is ohm, represented by the Greek letter. This is the ohm according to the Ohm's law. R is equal to B by I. If the potential difference across the two ends of a conductor is 1 volt and the current through it is 1 ampere, then the resistance R of the conductor is 1 ohm, that is 1 ohm is equal to 1 volt upon 1 ampere. Also from equation 12.5 we get I is equal to V by R. Now you see what they are saying. It is obvious from equation 12.7 that the current through a resistor is inversely proportional to its resistance. It is obvious from equation 12.7 that the current through a resistor is inversely proportional to its resistance. If the resistance is double, the current gets half. In many practical cases, it is necessary to increase or decrease the current in electric circuit. Okay, they are saying it is obvious from equation 12.7 I is equal to V by R that the current through a resistor is inversely proportional to resistance. If the resistance is double, the current gets half. In many practical cases necessary to increase the or decrease the current in electric circuit, a component used to regulate the current without changing the voltage source is called variable resistance. In an electric circuit, a device is called rheostat. No, rheostat is often used to change the resistance in the circuit. We will now study about the electrical resistance of the conductor with the help of following activity. So we are going to understand the resistance of the conductor, right? So here you see, take a nichrome wire, a torch bulb and 10-watt bulb and the ammeter 0 to 5 ampere range, and plug a key some connecting wire. Set up a wire by the connecting 4 dry cell of 1.5 volt each in series with ammeter, leaving a gap XY in circuit as shown in figure. So this is the firstly we are putting the circuit, nichrome wire and 10-watt bulb and torch bulb. This all we have taken. Complete the circuit by connecting the nichrome wire with the gap XY, plug the key. Note down the ammeter reading, take out the key from the plug. Note, always take out the key from the plug after the measuring the current through a circuit. Replace the nichrome wire with the torch bulb in the circuit and find the current through it by measuring the reading of the ammeter. Now, repeat the above step with the 10-watt bulb in the gap XY. Or the ammeter reading different for the different component, connect in the gap XY. What do the above observation indicate? You may repeat this activity by keeping any material component in the gap, observe ammeter reading in each case, analyze the observation. Okay, so what you are going to analyze in this activity, we observe that current is different for the different component. Why do they differ? Certain components offer an easy path for the flow of electric current, while the other resist to the flow. We know that motion of electron in an electric circuit constitutes a electric current. The electrons, however, not completely free to move within a conductor. They are resistant by the attraction of atoms among which they move. Thus, motion of electron through a conductor is retarded by resistance. A component of given size that offers a low resistance is a good conductor. A conductor having some appreciable resistance is called the resistor. A component of identical size that offer a higher resistance in poor conductor. An insulator of the same size offer even higher resistance. Okay, an insulator of the same size offer even a higher resistance. So this is how we are regulating the flow of the electricity, student, that you please practice more and more, then you will be able to understand. Thank you so much for watching, students.